Hello everyone, welcome back to the channel. Today we are diving with the next end-to-end machine learning project, and this video is going to be perfect for the beginner who is looking for to work with the real-time data set for the classification problem. I have picked up the latest trending or the latest data which is a very useful, and it is a real-time data set that is the student academic outcome, like whether they want to drop out the degree, they will enroll or graduate. You can use the machine learning for this one to solve this kind of the problem. I have picked up the Portuguese data set which has the 4,000 something records, and it contains them more than 35 columns. So we are going to do many things like the data visualization, EDA, model building, evaluation, and then feature importance. Before moving ahead, I would like to give you the blueprint of this project. So let me open my whiteboard. Here we go. Okay. So the data today, the problem we are going to solve, that is classification. Okay. So what you want to do, you want to predict the academic outcome of student. Okay. So classification means we have a three classes in our data set, that is dropout. The next one is graduate and enrolled. This data set is very useful if you are studying in the college, or maybe you are in the final year, second year, and you want to brush up your skill, you want to get dirty hands with the machine learning project, and you want to prepare your job portfolio, then this project is a super important and most beneficial project for you. Okay. So here, this is you are going to predict based on the many features given in your data set. Okay. So this is the problem you are going to solve. Okay. The second thing, this is called multi-classification. Okay. This is multi-classification. And this come under supervised machine learning. Okay. So this is a supervised machine learning. Now we will discuss the steps which you are going to follow today to build your model. Okay. So we will write down here the step one. In step one, you will start with the EDA. Okay. In EDA, you will load the data set and then explore the data set. Using head function, info function. Okay. And we will also check missing and duplicate values. Okay. So for these data and for the second step, I am going to write down for these, you are going to use the library NumPy, pandas. This is for data manipulation. And the second is your Seaborn and Matplotlib. This is for visualization. So these four libraries are mandatory. Apart from this, we are using many other libraries too. I will tell you. Okay. So now this is the first step you are going to perform. The second step is you will start visualization. Data visualization. Okay. In this, you will visualize univariate, distribution or feature. We can write down univariate analysis. This means you are going to pick up any one feature and show the distribution of that, and then bivariate. Okay. And then you can also do the multivariate. Okay. So this is you are going to perform here. So here you will use these two libraries. Okay. And in the step 3, we will do the transformation and cleaning. Okay. So in this, you will handle the missing value. You will say, I have written it here too. Here we are just checking. We are not handling it. Okay. And then we will check outliers and handle them. You can remove the outliers before visualization too. So you can see the visualization very clear. Okay. There is no problem. Okay. And then in the step 4, you will build the model because your data is ready. Okay. In this, we will encode the features too. If there is any categorical feature, then you can convert it into numeric. Okay. Now we will build the model. Here you will fit and transform the data. Fit and transform model. Okay. So I am using today the 3 model. That is, first one is your logistic regression, decision tree, and random forest. Okay. So this is logistic regression. Decision tree classifier, and then random forest classifier. For this, you will import the library. For this one, we will use a sklearn library, model libraries, train and test split. Okay. So there are many libraries. I will show you there. And the next step is you are going to do the model evaluation because your model is ready. Now it's a time to evaluate whether it is working good or not, or whether you need to improve it or not. Okay. So in this, I'm using the accuracy method, classification method, classification report, or confusion matrix. And then precision and recall. And at last, I will show you how to check feature importance. So you are going to check which feature was used most of the time by your model during training. So if you think by looking at the feature importance, if there are any feature which is not too usable, you can remove them and then you can fit onto the model again and check the accuracy. This is also a part of your evaluation. So these all steps we are going to use, and this is a multi-classification problem which you are going to learn today. And this is very, very popular. If you want, you can keep writing the steps with me when if you have a notepad or pen. Otherwise, you can rewatch the video. Joe. Okay. So this is the about the blueprint of the your project which you are going to implement today. So let me share my screen now again. Okay. So this is a project. Okay. I am using the Google Colab. If you are using the your local environment, then you can keep your data set either in the same folder where is your file, or if it is in the different folder, you can set the path when you are loading the data set. Okay, I have already shared the link here in the notebook, and this is about the data set. So this data set comes from the Portuguese higher education institution and was created as a part of national initiative to reduce university dropout rates, because university want to know at a early stages if any student is thinking to drop out, so they can help them, they can support them. It can be any reason, right? So this is your goal to do that. So this is the dropout rate. This is your goal to reduce this and detect it correctly in multi-classification, so you can tell to the university. That's why this project is very, very beneficial for you. Okay. And it includes the detailed records of 4,424 undergraduate students enrolled in 8 diverse programs. Okay. There are like the programs like this one: design, education, nursing, journalism, management, social service. Okay. And technologies too. The objective is to enable early intervention by applying machine learning to predict students' academic outcome. Okay. The model is classified into one of three categories: graduate, still enrolled, or dropout. Okay. So this is a three-class classification problem, multi-class classification problem, real-world complexity. Okay. It includes a little bit class imbalance, making it an excellent learning opportunity, okay, for you in predictive modeling. But if you want to know how to balance the imbalanced data, I have a separate end-to-end machine learning project. You can watch that. Okay, because we are not going to do today the imbalance to balance. Our goal is to just learn about the classification today. Okay. So here, first of all, you need to import the libraries. These are the libraries I told you. Pandas and Dumpy for data manipulation, Matplotlib, Seaborn for your visualization. I have imported these libraries to ignore the warnings in the outcome. Okay. This is I have uploaded the data set by clicking here. Okay. So you can also do that. And now let me close this one. Let me increase little bit size. Okay. So here we are loading the data set. Okay. I have used the read underscore CSV method because my file is in the extension with the CSV. If it is in the form of XLS, then you can say read underscore Excel. Okay. And then we will make a copy of the original data set. This is the basic and fundamental point you should always follow. It will be very, very beneficial. It will avoid your data leakage. It will help you if by chance, unfortunately, something happened, you need to reload your data set. You might collect it from different resources, right? You might collect it from more than one server. Then it is easy if you have a ready to go backup copy. You don't need to load again and again, merge them. So you can do it in a one go. Okay. So that's why. So we will work on this data frame, not this one. If you want, you can work on this. You can keep safe this one. Choice is yours. Okay. And then we are just using the head method to explore the data set. This is our first step, right? And then here you can see you have a marital status, application mode, order, course number, attendance, previous qualification grade. Here you have a mother father qualification. This is the semester results. Okay. And here this is the target. And GDP to inflation rate to unemployment rate to, right? So this is the target. This is we want to predict. And our goal is to tell the university, classify the dropout rate correctly and move correctly and mostly, so we can inform to the university like the admin section where the admissions happened, and they can just understand students' problem and they can offer them the support, right? Like a scholarship if they are intelligent, right? They are not able to continue their study just because of the money. Second reason, they might not be interested, they might be interested in other course. They are might be working, they are not able to proper schedule their program, right? So there can be the several reasons which we are going to explore today. And then we have the info method. Info method will give you the very good information. Here you will also can see the check the null values too. It will tell you the data type of your each feature too. It is telling you the total number of records and the columns too. Okay, that's why this is very popular. Here you can see your target feature is now in the form of object. Okay, so in classification, many students have this question: if our target feature is in the form of object, should we convert it into label or not? If you convert it, it's excellent. If you don't convert it, even then it's fine. It will automatically like handle it. Okay, so there is a no problem, but you should give the priority to convert them for easy understanding. Okay. And then here we have the null value. We are just checking the null value here. Okay. So we will check the null value sum. So we can see there is a no missing value. 0. Okay. So we don't need to worry about the missing value or handling them. Describe method. This is very popular method. It will help you to tell the statistics of the numerical data actually. Okay. How? Look at this. If we pick up the attendance one. Okay. So total records we have 4424 and check out the mean of this one. So its mean is 0.89. And now check up the maximum value 1. So this is not too far, right? So this means there is a no outlier. And it is also showing the standard deviation minimum value of this one, and 25%, 50%, 75%. This is an interquartile range. It is calculated itself. Okay. If you want to understand what is that, you can watch my statistics playlist. I will definitely share the link to video link. Okay. And this is a previous qualification. Now we can have the look of any, if there is any outlier. Let me see. Look at this mother's qualification. And here you can see the mean value is 19.56, but the maximum is 44. It's very far away. So there are outliers. Okay. And we can also like check for the here course semester 2. Look at this 0.5419. It's too far away. So now it is giving you the basic idea. You have to remove the outliers. Very important in this data set to remove the outliers because number one, it contains many outliers. If you are going to train your model using the outlier, your model is going to be biased because it will might think the higher magnitude of the values have, I need to give the higher weightage to that one. So it won't be able to predict correctly the dropout rate in that case. For example, many students, like let's say, were not able to clear the first semester, right? And the count of this one is very high, but it doesn't mean student is definitely going to drop out, right? But if there is a chance, right, and if you did not remove the outliers, in that case it will say that all students are dropout. Some students have exceptional cases like they are not well, they are going somewhere, anything can be, right? So we need to think in that direction. So this is very important. Okay. And now we will check the uniqueness of our target column using the value count method. And it is telling us graduate students record we have a 2201, 9. Dropout record is this much and enroll is this much. So this is pretty imbalanced, right? Because we have a more records about the graduate one. Okay. If you want, you can handle it here by using the SMOT method actually. And you only implement the SMOT method on the training data. Okay. This is the first thing. And second thing, just to think about it, I'm not going to do the balance today. I'm only going to do the prediction today, okay, using the visualization. If you want me to do that, you can drop a comment. Okay, so I will make a separate video on that. So here we are picking up this one. Now look at this distribution of the target class. Okay, so here what we are going to start now the visualization to. Here you are looking at the numbers, but if you want to visualize it, that will make more sense to you. Look at this. So you have a very less number of records about the enrolled. And here you can have the more records about the graduate, more than 2000, right? So this is, we are just plotting the overcount plot here by using the your Seaborn library. SNS, this is the instance of your Seaborn library. X is equals to target. This means that this one, x-axis. Okay. So target is divided into dropout, graduate, and enrolled. Okay. And then you have the total data. Here is the frequency. Okay. Now we will check and remove the outliers. If you want, you can do it like after visualization too, but I'm making it before my detailed visualization so I can make a good visualization. Okay, so this is the reason, but definitely it should be removed before model building. That is more important. Okay. Now look at this. Check and remove the outliers here. So we are using the Z-score library to remove the or check the outliers. Here is the SciPy stats. Okay. So Z-score is the inbuilt your library which we use to check the outliers. Z-score is a very popular method. We can also use the interquartile range method too to set the range of the outliers. I am going to use here Z-score. If you want to learn about that second method too, you can watch my machine learning playlist. I have used in many projects the interquartile range too. I just wanted to show you the Z-score today, so I have added it. So it is only applicable on the numerical data. We will separate the numerical data and then we are just measuring the length of that, and then we are rounding up the numbers so we can run the loop on that. Okay, because I want to plot the graph too. So for that I'm using here subplot and box plot to plot and show you the outliers in the data set for each feature corresponding to your given data distribution, and then we will remove the outliers here. Z-score is equals to numpy library. We are using instance absolute Z-score EDF numerical calls to numpy. We are converting it into the array because your Z-score does not support the data frame columns directly. Okay. And then we will create the here value r less than 3. This is a standard value of the Z-score between your positive to negative 3. So the value whose Z-score value is less than 3, it should say the filtered entries. This means we are removing the outliers, and then we will apply on that. Here I will show you the result. Now look at this. Here, this is a graph. This is for marital status. Look at this, too many outliers, right? So this is called box plot actually. If you want to take a deep dive, you can watch my visualization, data visualization playlist too. But if you are a first time you are watching this video, this is the box plot. Okay, and here this line is called median, and this is on the x-axis, this is the value, and this is the maximum value, and here on the other side minimum value, the interquartile range which I showed you in the describe method. This is that one. We are plotting it onto the graph. So the value when some data points like this is going beyond the maximum point, these all are outliers, these black dots. This is -1, right? This is below minimum value. So you can see here for the attendance to previous your qualification, your grade, nationality, too many outliers, mother, father qualification. If we look at it now here, the first semester, too many outliers. So that's why it's very important to set them before we build the model. Otherwise, you can see you have all outliers here up to many extent, and your model might get biased in this case. Okay, so this is very important. So this is just the graph, okay, all, and look at the this result. This is which we are interested. This is a before removing outlier, this is the data. And when your z-score remove the outlier, we are left with this much records. Okay, so it's a pretty like a reduction of the data, right? So it will happen, but you can see the here too. And now if you want to plot the graph again, this one you can plot it using, instead of only numerical column, you can use it using the your data frame clean too, and then you can look at do the comparison graphically too, if you have a wish. This is the just tip I'm giving you. Okay, so now this is a z score. If you are a totally beginner and you don't know what is z score, so z score is your how far the data point is from your average mean. So let's say your average test score is 70, and then standard deviation is 10, and then it will find the z-score like this. Okay, and this is a formula. This is your data point, this is the mean, and this is standard deviation. Okay, and now we will check the correlation. Although this is very like the small, right? You can see here, this graph will tell you the how other features are related with your target. Now we can have a look here. So we will track this side. Okay, so here. Okay, so if you look at this, it will just show you the your like the relationship of the each variable of your each like the feature, right? With this one, this is 26% correlated the marital status, right, with your application mode. Okay, and this is the way how you can check it. This is very common correlation heat map and very useful too. Okay, although it's very big, but you can try, and you can see here 94% your first semester. You can see now it is a very important feature for your target actually. Okay, so it has a big contribution, it might have a big contribution. Now look at this, the first semester here units 75%, right? And this is your target. And here you can see this one 78%, the next semester evaluations, then approved one. Okay, so here the below the darker this purple color means negatively correlated, which is a negative correlated. But if it is a lighter color and the darkish red or orange color, this is positively correlated. Okay, so this is a like a difference of the colors. Based on the color bar, you will understand about the your correlation with the target feature. Look at this. Okay, so now this is the graph about over correlation, how they are correlated with the target. So I have already told you your curriculum semester based result are strongly correlated with your target. 69%, 9%, 73, 94%. Okay, so they all are strongly correlated with the target. Okay, and now the next visualization is a scholarship, because this is a can be the another very good factor. If students have the scholarship, there are a very high chances like they will graduate, right? They will not drop out. So we can look at it too. Okay, although I have tried to cover up the maximum like the about your visualization. If you might come up with the new ideas, just drop a comment. I would really appreciate and want to know like which new visualization you are going to do. Okay. Definitely I will add those visualization in my next video. Okay. So here group and normalize. So first of all, we will group by the scholarship holder. So this is the feature you have according to the target. Okay. And then size unstack, apply the anonymous function lambda. This is an anonymous function. This means no name. If you don't know, this is the first time you are looking at this function, you can watch my Python playlist. But this is an anonymous function. We call it anonymous. There is a no name of the function. And then this is expression. This is the whatever you want to take action. And this is the next on axis one. Like we want to looking for the data on the column wise. Okay. And then we will plot the graph based on that. So we are using a stacked plot, and then figure size the proportion of the student outcome based on the scholarship status. Here, this code I have written to plot the percentage value on the graph. Okay, this is very simple. We are just running the loop over the row by row, and then group the columns and just calculating the percentage and then plotting it at the center. I will show you. Look at this. This will make more sense to you. This is a proportion of outcome by scholarship status. 0 is equals to no scholarship. 1 is equals to scholarship. Yes. Okay, because in your data set we have the values of the scholarship based on the 0 and 1. Okay, now we have set the legend with the dark green color dropout. So look at this now. The students who have the scholarship, right? There is a 12.2% chances they will drop out, right? But the student who does not have the scholarship, the chances is increased. So you can see now how strongly the scholarship feature is related with your target dropout, right? With this class. So there are a high chances of dropout, 38.7. This is too much high value than the 12.2, and enrolled student is 11.8. But yes, the scholarship student, definitely if your dropout rate is low, your graduate rate will be high, right? But here it looks dropout rate is high and graduate is low. Okay, yes, enrollment is good, better than the if the even the students don't have a scholarship, right? So this is giving you the very clear vision based on your uh, given results of the scholarship of your academic outcome of the student. Even if you want to show it to the stakeholder, they will very clear picture about it, so they can start working on that. Okay, so they can find out the students who do not have a scholarship, why they don't have a scholarship, and if they can like provide them some options about the studies, extra lessons or something, little bit discount, they might able to reduce the dropout rate. Okay, and then student outcome based on the gender, actually male female, definitely, right? Like sometimes many like the students like if we do the comparison, like the male students mostly want to do the mechanical engineering, right? Girls are less interested in these kind of the degrees, right? So we can here we are just mapping, because over all data is in the integer form 1 or 0. So I would say 1 is equals to male, 0 belong to female, and then we are plotting the count plot now. So look at this. So graduate outcome for the female is very higher than the male. Okay. And then enrollment rate of the female is also high. But the dropout rate is almost same. Here is the number of students on the y-axis. So you can assume now, right? So this means females are more higher count of graduation get graduated than the male. Okay. Now, if you want to do the detail analysis, you can plot the other graphs too, right? Like we did above. Now you can plot the semester wise too. You can plot like on the based of the father mother occupation too. So there are many plenty of options. Okay. And then here is on the count. So you can easily see 1600 female students have the higher count of graduation. Might be your data set contains more female records and less male records. Okay. It can be the reason too. Okay. And then here is the student outcome based on the financial stability. This is also very popular feature, right? Why? Because many students are not able to like pay the fee on time, because they are working, they are student too, and they are studying too, right? So they have many expenses. So to sometimes they might not be able to fill the fees, right? Pay the fees. So we will try to make a graph of this one. I have written the same code 2 times. That's fine. Okay. And then we will group and normalize. We will normalize it. This is using the same. Okay. And group them, and we will plot the stack bar for this one too. Look at this. So this is no means they are not financially stable. They are not able to pay the fee on time. And yes, there are. So dropout. So the students who are not able to pay the fee, so this can be the one other cause. So now when your stakeholder will see there is a 86.6% of the students who are not able to pay the fee on time, so they will drop out. So now it's a university's responsibility or college, so they can solve this problem of the students. They can check their like the about the financial status, might be they can offer them some other classes, or might be they can give them scholarship based on their academic record, or they might reduce little bit fees so they can pay it on the time. Okay, so this is another very good like the visualization or the distribution check. Here 24.7 chances, and enroll is 19.3. Here enrollment rate is also low, and graduation rate is also low. Okay, so this means this financial stability is very your target is very highly dependent on this. Definitely, if any student is not able to pay the full semester fee, the university will kick out them, right? So this is the rule of every university. So we have to pay the fees, right? So they can work on that, but our goal is to just check which factors are highly like the making a like the effect on the dropout rate. Okay, and then we will check based on the attendance. This is can also be the other cause. Okay, so here we will again like map them, and then we are just checking the attendance. We will create the again stacked bar graph. Look at this. So if the students are not attending the classes, right, might be they are working, they are busy, sometimes they don't like to attend the classes, they thought I will do it later on, right? So 42.9% the students will drop out. This also give the university the idea about it. If they are not regularly attend the class, right, they might not be interested in this degree. But the students who are attending the class, 38.8%, okay, chances they will not drop out. Here the enroll rate is reduced, and the graduation rate will definitely reduce. Definitely, right? Because dropout rate is very high. Okay, so this is also impacting the target at a deeper level. This is another very good visualization or like the analysis of your this data set. And then we will talk about the student outcome based on the age. It is also important. Many students are older, right? They would like to study. And then here is a look at this. So there is a dropout rate. The dropout rate is between here you can see 20 to 70. There are many students who enrolled who are after 45. So there are many students who will drop out after 45. Might be they are working, right? Due to job, they may get a like a transfer. They need to go from there. They cannot attend the classes or every time they enroll, but their dropout rate is this much. And for the graduate outcome, definitely it will be low, right? So the graduate outcome, how many students generally get graduated below 30? Okay, there are many students who are above 62, so these all are our outliers. Okay, and many the students who will enroll, their age is between 20 to 55. Okay, so the mostly the dropout rate of the higher based on the age too. Okay, this is the outcome, academic outcome based on the age of the student. Now we will talk about the student outcome based on the semester result. This is very important. I am going to show you the semester result of the two semesters. You can draw the other graphs like the same way. Okay, so you can copy them and just check out the results. Now here we are just pick up the curriculum units first semester. You have seen it above in the correlation map. It was showing the 90% highly correlated with your target, right? So I have picked that one, and then we are plotting the histogram. Here is the legend. Green belongs to dropout. This is graduate and enrolled. On the x-axis we have a semesters. So this is the first semester because each semester is of 5 months, 6 months, right? So if we look at this, the dropout rate is mostly in the first semester if they are passing just let's say between 2 or 3 months, right? 2 or 3 months. Here you can see, I'm assuming it is a month and each semester. Okay. So we have a first semester, second, third, fourth, fifth, sixth semester. Okay. 3 year. So here dropout rate is very high early in the first year of the first semester. Okay, and but dropout rate is very low if they have already done the, let's say they are a second year of the second semester, and it will decrease when they are coming in the next semester. So it is going to give you the very clear vision, which is the main objective of this, like the data set. The students who is dropping out, they will drop out at a early like the stages of the semester, right? It will slowly decrease when the students are moving on to the next semester. So there are less chances. So this is giving you the very good idea. Now we can check for the second year too. This is the same case. Okay, so this is the same case it is showing. So if we look at this, it seems to be here. This is showing in the first semester little bit high dropout rate. Here is it is decreasing. Okay, sorry. Here this is, I have divided it into three months to five, right? These semesters. So this graph will give you the idea about it. If you want, you can plot the box plot too. Okay. For this kind, you can just pick up the whole data, run the your for loop, and just plot the your box plot too. But if you want to plot now graph for the other all semesters approved, third, fourth, or fifth, sixth, you can do copy and paste the same one. Okay. So it will give you the clear picture visually too. And then if you want to make it a more interactive, you can use a Plotly too. You can watch my Plotly playlist, and I have just recently uploaded the time series project too. So you can also look at that too. Okay. And then we have a model building now. Because we don't have any missing value, we like don't have the duplicate values. If there is, you can drop that. There is a no problem. Okay. Now I am going to convert my target feature into numeric because it is a categorical. We will convert it into numeric. And then these are the important libraries you need to import. sklearn is a machine learning library. Train and test we need to split it into the train test, preprocessing, standard scalar, label encoder to convert if we required to convert any categorical data into numerical. And we also need to scale over numerical data too. It's very important. Okay. If the units are in, if your feature have the different units. Here we are importing the random classifier because we are going to apply this logistic regression, decision classifier. This is for evaluation. Accuracy, score and classification report. This is also for evaluation. Okay. Now I'm just looking at it, my data again. So here I have created the, actually keep the backup of my features like the gender map, financially stable, attendance. Might be you are thinking how, from where did they come? From here. Okay. So here I will remove this one. This is the same piece of code. I think I have pasted it mistakenly. So this is your original column actually. In original column, we have the 1 or 0. And we are converting into the label encoder 4 over graph actually here. Okay. So that's why I have created the backup column attendance. This is new column. Same for the here financial stability. Okay. This one. And then we have also created for gender. So this is just what I did. I convert the 1 0 into yes, no, male, female. That's it. And then I'm creating this one. Because I did not want to actually make a changes in the existing my column. Okay. Because otherwise I need to do the label encoder again. So I'm avoiding that actually. Okay. If you want, you can make a changes in EDA definitely, but you need to use a label encoder or hot encoder again when you are fitting onto the model. Choice is yours. It found me easy. That's why I always make a copy of data frame. Okay. So this is good. And now For the model building, we will drop them because we don't need that. We just create it for the visualization. So you will drop the target column 2 from the X feature. X is equal to 1, gender map, attendance, and financially stable. And then this is our target feature. Now we will use a standard scaler. We will fit onto the X feature because these all are numerical. We will scale them. Here we are splitting the data using the train and test split. Here we are using the scaled, which is the scaled method. Y, which you have created here. Stratify is equals to yes. You can use it. I'm just why I'm using this because my target feature is not stable, right? It's imbalanced. We have a very less record for the enrolled, right? And the your graduate one. So what it will do, it is not going to add like the data. It is not going to do anything. It is only make sure when it is splitting the data, X train, X test, Y train, Y test, it will keep the balanced class. Like let's say if you have the Y test or X test, it will make sure it does not contain only the your that one data. Let me look at this one. I will make you understand here. So it will make more sense to you. Instead of this, we will see here value underscore counts. Okay. So we will do the sum of this one. Okay. Ah, it should not show this one. So we can do the unique. Okay. Oh, it's a data frame. This is my mistake. I forgot this one actually. Sorry about that. So we have a target dot now unique. You can use the unique or ununique. This is your choice. Okay. And maybe this one. Okay. So we have a 3, but we are interested in the count actually. So what we will do, if you want to look for the count, we will use the another method. Okay. Now look at this. We will do the value count here. This is just for your understanding. Now you have a 2209. So this is the record of your, if we go back, this is for dropout. You have a maximum records of dropout. For graduate, you have the 1421. For enrolled, you have a less. So when you use a stratify is equals to yes, it will make sure your Y train or Y test or X test should also contain the classes from this one or this one, all 3 classes in X test and Y test too. Okay, otherwise sometime what happen in imbalance, it will just separate the one class in the train only. So your model will get a train only for the dropout. It might happen because it's a random, right? So we want to make sure balance of the data, but it is not going to add a new data. Mind it is not getting adding any new data. It is just making sure your all array, which is your splitting X train, Y test, X test, Y test, or your X test, it should contain the all classes. Okay, at a equal level. So your model get trained at equal level. This is the only purpose of stratify is equals to yes. So we are keeping the 20% of test size. This is random state. And then I created the dictionary for the models actually because I want to apply the all 3 models. So here I'm using the logistic regression. I just declare it. Maximum iteration, this is a parameter, then decision tree classified, then random forest. We will keep it very simple because this is it might be the first time you are watching this for the classification. And this is the result. We will create the empty dictionary, run the loop on the model. So we will pick the model dot items because this is a dictionary. It will fit onto the X train, Y train one by one, all models. Okay. And then we are just storing the accuracy score in this one. And then we will sort the result and we will print the result here. Now this is the result. So random forest is giving you the 77% accuracy. logistic regression is giving 76 and 67. This is the most easiest way and the most simplest way if you are interested to run many model together. And now you can pick up the random forest because it is going to, it is giving you the highest accuracy. Okay. Now, if you want, after this, definitely we will do the evaluation too. But if you're interested, you can, after doing all these steps, your next step will be you can evaluate the model after balancing. Okay, but we have this fresh data. Actually, this is recently fetched. It's only 10 to 15 days ago. It is come up on the Kaggle, so that's why I have picked up. Okay, so this is 77%, and now we will do the model evaluation. So for me, the highest accuracy is the best because accuracy is the one of the classification metric. It is telling me 77%. I will fit it again and then I will print the confusion metric because the accuracy is just giving the single number 77%, but I don't know how many dropout rate it is able to predict correctly, how many enroll or that one, other one graduate, right? So we are interested in that specifically. For that, you will use a confusion metric. So this is only applicable on your Y test and prediction one, and then I'm setting up the label for your convenience, and then we are plotting the heat map. Now look at this. So this is your actual values. This is predicted on the x-axis. Actual is this. So your model random forest was actually able to predict 214 values correctly for the dropout. Okay, this is our goal actually. We want to predict the dropout values correctly. We want this one more, right? And then 48, it is saying, although this should be the dropout, but it is saying they are enrolled. So this is incorrect. And this is also incorrect because we don't want that one, right? If this is dropout, we want, it should be high. If there are, let's say, 1,000 records, out of it, 600 records of dropout rate, your model also should, like say, this is the total, how many records? 600, right? But you can assume like if it is only able to predict correctly the 500 records, so you are missing 100 records, which is not good for university, right? So this is for the enroll one, and this is for the graduate one, but we are mostly interested in the dropout in this section. And enrolled, it is able to predict correctly 416, this is good, and 55 it is able to predict graduate. Rest all are a false positive and false negative. Okay. Uh, Now we will do the another evaluation method, that is precision recall. Okay. So here the precision we will apply recall and F1 score. Precision means like your which value. The precision is the ratio. You can see the formula here. This one TP divided by TP plus FP. TP is true positive. This one where TP is the number of the true positive, FP is the number of false positive. The precision in intuitively the ability of classifying not to label as a positive as a sample that is negative. Okay, so this means that here if anything is a positive, your model should predict correctly this is positive. Okay, so this is called precision, but we don't want the like precision here high, we want the actually recall high because we want to know which values of the dropout your model was able to predict correctly, which were actually dropout rate. It is not saying them the dropout rate to they are graduate, they are enrolled. We don't want that. That is called recall, where your model was able to correctly predicted the values which were actually positive. Okay, how many correctly? Let's say you have 100 records. Out of these, 80 records are your in actual 80 records are dropout. But your model predict only the 70 records. So it is missing 10 records. So 10 records, it is saying they are graduate, maybe enrolled, right? So what you want now? You want the high recall. Okay. And here we are calculating the recall. Now see, precision is 83%, recall is 74%. But in enroll, its recall is very high. This is also good, right? and then 35% is recall, in this case graduate. Okay, so your goal is to increase this one. Okay, and then here we will check the feature importance here. Actually, this is the very popular, like the method you should always prefer this, actually I would say. Okay, so because it will help you to understand. Earlier, before model building, we use the correlation method. Okay, there are other method too, you can also do that, you can check. But after doing this, it will tell you the feature importance based on the model. Actually, during model training, which feature your model has used most of the time. So now you can see your model has used most of the time curriculum unit second semester approved. This has the highest score, right, above 15%. And then first semester, then second, you can see these features are very, very important for your model, and it has used many times. The least feature your model has used, curriculum unit second semester enrolled and GDP, father occupation, course. But if you even assume the top 10 one, that is also good. All right, you can try. You can just let's say you can drop the last one feature, because it has a feature importance below 40%. This is just, I'm just giving you the suggestion. You can drop the features which is used very less. Okay, these two, and then fit onto the model again. This is also the part of your evaluation, actually. That's why I'm showing this. Okay, so we have another method too, SHAP method too. I have used in my another end-to-end machine learning project. You can check out my playlist. Okay, so this is about over like today's project. Okay, so what we have done, just a recap. We have load the data set, we have explored the data set, the how the like the your target feature is strongly dependent on the which feature, right? The semester we have did the analysis using the gender based, using the age based, using the your curriculum, sorry, semester based, right? And for the scholarship, financial status, there is a father mother occupation too, you can also use that. Okay, but I have picked up the most important features, actually. Okay, so you can draw them. If you want to like make me a video by balancing this one, just to drop a comment and just let me know, drop a comment which model, more model or more visualization you are going to use. I would appreciate. Okay, and you can check my post tab too. For the I used to post the MCQ on the Python and machine learning. You can solve those questions too. It will help you to like increase your technical skills too, and enhance your knowledge too. Okay, and thank you so much. Keep watching, keep learning, keep patience with science, data science. If you like this video, hit the like button. It motivates me to make a more videos for you on the different projects, so you can learn. My goal is just to make you, give you the knowledge, especially for the beginners who are struggling. Like also they are excited to get dirty hands with the machine learning projects practically. So I wanted to share my all knowledge with all of you. Okay, so just like it, comment it. So it will definitely, it motivates me actually to make more videos. Thank you so much for watching this video. See you in the next video.